Hello everyone, welcome to another session of Sateesh Tech Talk. Today's topic is called AI tools every developer should know. The key word here is developer. Quick agenda before we dive in. This is a developer focused session, no deep learning or math involved. We will walk through the end-to-end AI stack from user requests all the way to production systems. And I will show some examples in both Java and Python so AI feels less like magic and more like software engineering. Let's start with why AI tools matter at all. Out of the box, LLMs are powerful, but they are also extremely limited. They are stateless, they don't remember past conversations, they don't know your databases, APIs or business rules. This is why demos look amazing and then fall apart in production. Tooling adds three critical things: memory, orchestration and control. That's how we evolved from simple chatbots to copilots and now to AI agents. Without tools, AI stays a demo. With tools, AI becomes software. Now let's discuss what makes an LLM application. This slide is extremely important. An LLM call is not an application. Think of the LLM as a brain. A brain alone is useless. You also need RAG to connect real-time and private data, a logic layer for workflows and agents, a user interface or API so users can interact safely. If one of these is missing, the system either hallucinates, leaks data or becomes impossible to operate. An LLM app is a system, not a single API call. Now let's walk through the full end-to-end AI stack step by step. Everything starts with the user. This could be a web app or an enterprise portal or even an IDE plugin. At this point, the user is just asking a question or triggering an action. Nothing AI specific happens here yet. The request first hits the API layer, which is step 1. This is the front door of the AI system. Here we validate input, authenticate the user, apply rate limits and log requests. Whether it's a fast API or Spring Boot, this works exactly like any backend service. The LLM never sees raw user input directly. Next is the step 2 RAG pipeline. This is where we fetch relevant, real-time or private data. The user's question is converted into embeddings, matched against a vector database, and only the most relevant context is selected. This is how the AI stays accurate and grounded. Now the request reaches to step 3, which is LLM. The model receives the question plus the retrieved context and performs reasoning and language generation. The LLM does not know your data by default. It only knows what the RAG pipeline provides. This keeps responses controlled and at this point, the LLM may decide to call tools or agents, which is step 4. These tools can query databases, create Jira tickets, call cloud APIs or trigger background jobs. Think of tools as the LLM's hands. It reasons first, then acts through controlled interfaces. All real work happens in external systems, which can be databases, services, schedulers and APIs, which is step 5. Observability tools like OpenTelemetry or Langsmith track what happened, how long it took and how much it cost. This is where AI meets real production operations. Finally, a grounded response is returned to the user. The response is based on real data, controlled reasoning, and observable actions. From the user's perspective, it feels like magic, but underneath, it's just well-designed software. When you put all these steps together, you are looking at the full end-to-end AI stack in action. Now let's see how the end-to-end AI stack comes together using Java and Python. To make this easier to understand, we will split the stack into an upper layer and a lower layer. This slide shows the upper layer where user intent and control are handled. Starting at the top, user through user interface is just how humans interact with the system. Python teams often move fast with simple web UIs, while Java teams usually plug into enterprise portals or IDE plugins. Next is the API layer. Whether it's a Spring Boot or Fast API, the responsibilities are identical. Validate input, authenticate users, and protect the system. Auth and security is non-negotiable. OAuth, JWT, and role-based access work exactly the same in AI systems as non-AI systems. Then we reach RAG orchestration. Python uses frameworks like LangChain or Llama Index. Java often implements the same logic explicitly using Spring AI or custom services. The key takeaway here, the architecture does not change between Java and Python, only the tooling does. Now let's move to the lower layer of the AI stack, where AI becomes a real production system. Let's start with embeddings. Both Java and Python do the same thing here, convert text into vectors. Python often uses native SDKs, while Java typically uses SDKs or REST clients. Next is the vector database. Tools like Pinecone or VV8 act as a semantic memory. This is how the system remembers information without retraining models. Then we have tools and agents. In Java, these are usually services and schedulers. In Python, they appear as agent loops calling APIs, databases, or Jira. External systems stay the source of truth. Nothing changes here. Finally, notice deployment and observability. Docker, Kubernetes, OpenTelemetry, same DevOps rules apply here. The key takeaway, AI changes how we reason, not how we operate systems. Upper layers control intent, lower layers run production. Together, they form the full AI stack. Let's wrap up with 4 key takeaways. First, LLMs alone are not applications. Second, start with RAG before agents. Third, design for safety, cost, and observability from day one. And fourth, don't overthink it. Use the same cloud native patterns you already trust. AI doesn't replace good software engineering, it rewards it. If you can build backend systems, you can build AI systems. Thank you all for watching. I hope you now have a complete picture of the end-to-end AI stack and the tools needed to build it. This is Sateesh signing off. See you all in the next Tech Talk.